Okay, hello everybody. I'm going to be talking through Chapter 10, Introduction to Data Visualization. And I'm going to be discussing just a brief history of some data viz and some interesting examples, and then going through some features of ggplot2 and the grammar of graphics, how it works with practical examples using material from the chapter, but not following the exact structure, just to demonstrate how you can use different features for the different types of plots that are presented. And then to see examples of visualizations for exploratory analysis and how you can tweak them, and other things to think about, things like accessibility and how to improve your visualizations for different users. So the history of data visualization. So I found some really interesting examples that are quite old. Just an example here of petroglyphs made by the Paiute and Shoshone people of North America, Eastern Sierra Nevada type regions. And there are many examples across Central South America, Australia, of people recording the cycles of the sun and the moon, and growing cycles for crops and animals, and they would leave these things and create these things for generations to understand certain times of year, habits of animals and plants of when they could eat. And there are some of these are centuries old, some are many thousands of years old, and really fascinating examples of very early data visualization based on observational data and to convey information that could be of use to other people, which is really the purpose of data viz. But we also have examples, if we fast forward a little bit to William Playfair, for example. So this is an example from a book that he wrote with many different types of visualizations, from the Commercial and Political Atlas, published in 1801. This is a line chart drawn on graph paper showing the difference between imports and exports in England from 1700 to 1800. And the lower line is the imports, the upper line are exports. And you can see the sort of fairly sort of gradually increasing until around 1760. And this is the point at which the East India Company took control of most of India around 1757. And the British Empire just kind of took the wealth of India and used it for its own ill-gotten gains. And then fast forward a little bit more to around the late 18th century with the Napoleonic Wars. So there's a sudden increase in imports and exports, and that's when people from areas that have been colonized were then press ganged onto ships for trading because the voyages were quite dangerous. So a lot of people were taken from Africa and other parts of the world to sail on those ships, and for further colonial expansion around the world. Which brings us on to Florence Nightingale, who created what are called rose diagrams, but she didn't refer to them as rose diagrams. But what they were meant to do was to show causes of mortality, numbers of people dying from different causes during the Crimean War, from sort of 1850s, mid 1850s. And they're quite interesting visualizations. There are, and I've all of these slides again, like I've done before, will be I'll make a pull request to the GitHub repository, because I've put quite a few links in just for further reading and interest to see other notable women who made significant contributions to data visualization and invented different types of visualization to communicate findings from their work and things that they were doing. Florence Nightingale was also quite a staunch supporter of British colonial expansion, and didn't hide that fact, which brings us on nicely to a really interesting, notable academic from the USA, W.E.B. Du Bois, who created many visualizations, really interesting designs that you used to be able to look at on the Smithsonian website, but they don't seem to be there anymore. But he was a sociologist, a writer, a photographer, collected data on populations of Black and African American people, following the formal end of slavery in the United States and Reconstruction period. And he's written many books about this, really interesting guy. And he created a lot of these visualizations. This is a famous one known as the Dubois Spiral for an exposition in Paris in 1900. And there are so many really fantastic things that he did using data to dispel negative stereotypes about African American populations and to communicate the situations that they often found themselves in because of slavery and because of racism, and wanted to demonstrate, to show people as they really are and not how white supremacist society wanted them to be seen. So that's and a lot of his work is still relevant. A lot of his writing is still relevant for today and very interesting stuff. So moving on to ggplot and the grammar of graphics. So the format I'm taking is to look at each of the different charts, 3 different chart types presented in the chapter, to demonstrate how to modify them and customize them. And ggplot uses quite a structured approach with layers, where you have the data. You start by specifying the data, you specify your aesthetics, your x-axis, your y-axis, and geometries. So what kind of chart do you want? Points? Do you want lines? Do you want bars? And how to customize each of these things to tweak the fonts and the styles with themes and guides. And there are many, many different types of charts and visualizations that you can create with ggplot. It's a fantastic package, and it has a lot of depth. So it does take some time to really get used to know the package and all the different things you can do and things you can't do, things that don't work, or create errors. So I do seem to find myself discovering all the things I can't do, and also quite a lot of things I can do. So some general guidelines for visualizations, as I mentioned earlier, it's at the basic level. You're trying to communicate information, often about data, important things that you want people to understand. So it's really important that your information is clear and to not mislead people. And often you need to, it helps to talk to people and ask, what do you understand from this? Get some feedback, get some thoughts, because it might be clear to you if it's your work, but it may not be clear to somebody else. So it also helps if it doesn't take a huge amount of effort to understand or to read a chart or a visualization, because sometimes you do have to put a bit of work in to looking and reading things and understanding, but you don't want to have something that's excessive and places a high cognitive load on people, because then they won't engage with it, and the opportunity for learning is then diminished. Aesthetics are there to enhance the information, but not to distract. And it can be a difficult balance. And what might work for one person will probably not work for somebody else. So you can use different formats and different styles to communicate depending on your data and your research questions or the kind of work that you're doing. And you also don't want to overload people with information. So you don't want to be reading lots and lots of things on a chart that could be better presented in a table or in a paragraph, a short descriptive paragraph to explain things. And also, like I've mentioned, alternative formats. It's always a good idea to have a nice, proper structured table with a chart, depending on what you're doing. If you're doing a show and tell at a big conference, then a nice visual with some exposition behind it can be quite pleasant, can be quite nice to engage with. So common types of plots that you can actually create with ggplot, and I'll just be looking at the first 3, but many of the principles apply to the other types of plots. And which ones you choose really depend on what you want to show. If you're doing exploratory analysis, then you may want to be looking at scatter plots. If you have pairs of continuous variables, you may want to look at histograms to understand the spread of your data, or your distribution, box plots to understand more about the range and the medians and means and things, quick visuals, to more complex and sophisticated things, network diagrams, choropleth maps, which I absolutely love. I love maps. Who doesn't love a good map? And then other things like Sankey diagrams to show data flows or flows between different categories from start to finish, for example, and tree maps that are often used on sites like the Global Burden of Disease, they have some really nice tree maps to show different kinds of diseases or conditions for different countries in different categories. So lots of really cool things you can do. So I'm going to be looking at using the example lung cancer deaths by prevalence and age in Germany. So this is the data set, and the variables used are age categories in 5 years from age 10 to 85 plus in 5-year increments. The sex category has 3 levels, both female and male. Prevalence, which is a rate estimation, and this estimated deaths, which again is a rate estimation. So just starting off with a simple scatter plot on how to do it. So library ggplot2, that's the package. And then you can do it this way. You can select your data and then pipe the data into ggplot and initialize it, or you can create a data variable within your ggplot function and then specify the aesthetics afterwards. But for this example, we're going to pipe the data into ggplot, initialize it, and set the first set of aesthetics to prevalence on the x-axis and deaths on the y-axis. And then this little plus sign updates ggplot. So whenever you create this, you can create an object, a plot as an object, a base plot, and then just keep updating it with a little plus symbol and tweaking it as you go along, which saves you having to constantly retype code and have too much code in your files. So you create a point layer, a geometry with a point layer, and we're going to set the shape of the points according to sex category and add some titles for, well, the main title and the x-axis and the y-axis. So this is, there's a bit of an issue. It should be age, not prevalence. So we're looking at just a basic plot, the rate of the prevalence rate and the death rate. And it's okay. I think the points to my liking are a bit small. I don't like the standard basic ggplot background, which is grey. I don't particularly like that. So things that I'm going to show to demonstrate to improve this, to make it easier to understand, just a quick look at prevalence and deaths. I'm going to change the size of the points and the color of the points within the geometry for points, and use some theming to change the background. So to make a very plain background using theme classic, or you can also do the same thing with theme BW, but you also need to use extra parameters. And there may be an advantage to doing that as opposed to just applying a standard classic theme, depending on what you like on your own aesthetic choices. And also have a look at things you can do to check the readability of colours if you are going to use colour for your charts. So I've added the shape and the colour aesthetics to the main plot to specify those. And within the geometry for point, I've increased the size of the points and applying the classic theme, a basic theme, but I want to also change the font with the text by adding an additional theme parameter and changing the size of the font. And also I want the axis text on the X and the Y axis to both be black, because they're a very, very dark grey on the basic one. And so that's what that looks like. And I think that's a lot clearer now for me. I can see the blue squares. I can see that there's an overall where you see the prevalence increases for lung cancer, the death rate is higher. And there seems to be a pattern here for males with a higher death rate in Germany than for females. But I think it's something that came out of the COVID pandemic, is that men tend to smoke more than women generally, although it depends on country by country, and what things that are socially acceptable in some countries are not in others. But generally, men tend to smoke more than women. However, there is a cluster of points around this lower end that you can't really see very well with a scatter plot, but there are other functions you can use like Plotly, where you can zoom in and out and actually scrutinize what's happening, where you do have these overlapping areas of points. but it's fine. It's an improvement from the basic one that you get with standard ggplot. So to create the same thing with theme BW, and the reason why you might want to try this approach is that you can play around with some of these elements. Not that you can't do it with theme classic, but you can sort of step by step have a look at each of these individual elements, like the plot background, and you can change it from blank, and look at some of the different things you can do to modify. You can change the lines and set different colors, thicknesses if you want to, and let your creative side run free and try each of these things to see what they do, because there may be a good reason why you might want to have grid lines. You might think it's easier for people to actually look to see certain numbers or certain values, and that's how you can sort of tweak some of these themes. And it's also useful if you want to learn how to create your own themes, which I'll come on to a little bit later. So that's exactly the same chart using theme BW and extra parameters, and it's okay. But if you want to think about colour blindness, just some simple tips and things you can do to check for that and have a play around with some additional packages. So the Colour Blinder package checks the readability of colours for different types of colour vision deficiency, colour weakness, or colour blindness. It's helpful to have the colour space and cow plot packages. And I've added some code in to show where to get those from. So what Colour Blinder does, you can specify the severity of colour vision deficiency. So the default value is set to 0.7 or 70%, with 0 being no colour vision deficiency. 100% is that you can't detect the colour at all. So you can also use the dichromat package as well. And what you can do with that package, and I've put links in that you can check once I've uploaded the slides, is you can put a whole color palette in, and then you can simulate these different color vision deficiencies with whole color palettes, and it will show you that some colors, depending on the type, red, green, or blue, or monochromacy, whether any of those colors look the same or just impossible to differentiate for those kinds of issues. So we're going to use the Colour Blinder package and the CVD grid function. And by putting the scatter plot into the CVD grid function, what you get is an output like this, which just shows you overall. So Deuter anomaly is green weak. This is red weak, protanomaly, blue weak, and people who can't see color at all, so monochromatic vision. And it's useful just to get a quick sense of, does your palette work? Do you need to make any tweaks? Do you need a different version? Sometimes, you can use just shape on its own, which might be fine. So there are all these different things you can try, and it's really just a pointer to help you figure out how to improve your visualizations and what to do. And I think in the past, when I've presented, I used to work in the land-based sector presenting to farmers, and I've used colours and shapes and described the colours and shapes as I've been talking. And there was one occasion a farmer said, "Oh, well, if you hadn't described the shape, I wouldn't have been able to see because I'm colourblind." And they all look the same, they all look brown. So it was really useful actually having the shape as well. So it's something to think about, and it may be useful. So the options are, don't use colour. You may just be able to use shape. You could put black outlines around the shapes. I think that can look a bit messy. You could choose a better palette. And there's one I've picked out below here for qualitative data where you've got categories, is the Okabe Ito palette, and it was designed by two Japanese researchers, Okabe and Ito, who are both red blind. And there is a scale function in ggplot that you can use that will automatically just select 3 colors for you, so you don't have to pick. But these are the hex codes for the palette. And I've also added that into the alt text as well. The Viridis palette has become very popular for continuous data, and there are variations on a theme of that palette. And also the Colour Brewer package has many colorblind friendly palettes that you can use. And you can control the color and shape using Scales, and Scales is a fantastic package. It's already integrated into ggplot2 and tidyverse. And you can manually set the colors and the shapes using scale, which is necessary. You need to use both to be able to modify the legend properly, or you end up with two legends, one for scale, well, sorry, one for color and one for shape. So you can take your scatter plot as an object and then update the labels, and you have to apply the scales for color and shape by specifying the legend title in both cases and the labels in both cases. But for the color, you can manually set the values using hex codes or the color names if you know them. And you can also set the values for the shapes. And if you look into the documentation of ggplot2 for the shapes, there's a whole table that shows the shape with the number, so you can customize the different types of shapes that you're using. And that's what that looks like. You've changed the colors, the shapes are the same, and you can check again with the colorblinder package how well this works, and it may not work at all for people with monochromatic vision, so you might need to present your data in a different way, and that's fine. And as I mentioned, there's an Akabe Ito function that exists that you can use that will use color and fill and those things automatically, so you don't have to go looking at color palettes. But I like looking at color palettes. I think it's quite a lot of fun. So how can we look at the lung cancer data with bar plots, and does that show us anything else? Well, to create, I've never actually used the GG pattern package. I didn't know it existed, so this is new for me. So how to use it, again, it's based on ggplot, GG pattern, pipe the data into ggplot and set the age categories, the estimated death rate, and grouping by sex. And with GG pattern, the geometry is the column pattern. And we want to differentiate the patterns by the sex variable, the sex categories, in stacked bar charts with a white background, and the patterns themselves will be black. So again, you can play around with these colors to your heart's content and come up with all sorts of jazzy variations on a theme. And the labeling without any kind of themes again this time. And that's what that looks like. And some people are going to love this. I'm not sure I do, but that's my own personal preference. I think that there are some probably interesting use cases for this. And while I was preparing the slides, I was trying to think of one, and I kind of have, but I think I'd need to put it to the test before I actually put it out into the world that this is what you can use it for. But that's some people are going to love it. I just find it quite busy. I like plainer things generally, but that's my preference. So some things I would do for myself with these sorts of data to be able to compare between these death rates across age categories for males, females, and all together, I would probably use geom bar to create bar charts, and I would use faceting to separate them, facet grid. There's also facet wrap, which is slightly different. Facet wrap will take any number of variables. So if you have a single variable with many levels and want to arrange plots in a more space efficient manner, facet wrap is good. And it will also create plots where you've got missing data and no data to show. Whereas facet grid will, where you have two discrete variables and all combinations of the variables exist in the data, facet grid is better for that. So I've used facet grid. And also I want to adjust these age categories so that they're often at an angle a bit, and put the origin on the y-axis down to 0, so the bars start on the x-axis directly without that little gap. For some charts, you might not want to do that, where you obviously have negative values. You would want the origin, you would want the y-axis to go negative as well as positive, but you can customize and tweak those. So to create that, again, piping the data. This time I'm not grouping by sex because I'm going to facet by sex, but I'm filling the bars just white, plain bars, and using the stat identity function tells R to calculate the sum of the y variable, so the sum of death rates overall for each age category grouped by sex, and then a black outline around the bars. And to set the origin of the y-axis to 0, you set the limits start and end to 0. And then the labels, and here the faceting, separate panels for each sex category. So using facet grid with the sex category, and I'm going to go with theme classic, but update the font, the style, the color, and then this is the axis, x-axis text at an angle, and I've adjusted it horizontally so that it's sitting below the axis, otherwise it sits on the axis, and that looks a bit messy. I do like white space, quite a lot of white space on things. And this is what you get, which I think is a lot better than the kind of the base version. And you might be okay with these are strip text labels in lowercase if you want to change them, or if you want to change the names at all of the strip text labels. Here's one approach, although I did get an error warning saying that the API has been updated, so this might not be the right way to do it, but I've done it. I've created the sex categories in a list. So I've said these are the original categories. I mean, you could put apple, orange, and banana, or whatever different names you want to put. Create a function that will take each of these names and make a list of those names in the label category, return those values, and then you add them to the facet grid. You again update the bar plot, facet grid, and I've changed the order to show the what these bars would look like faceted with the bar clusters of bar charts next to each other instead of on top of each other, and using the labels from the label value that I've just specified. And yeah, so that's different. I don't prefer this, mostly because the age categories are repeated multiple times across the x-axis. I prefer the other way of looking at it. It just looks a lot simpler, less crowded, and easier to see. But generally, I think it's a nice way to present the data because you can actually see across different age categories and the death rate and compare between each of those categories. So, you can sort of very quickly view something like this and understand, get a sense of what's happening. And then finally coming on to line plots, again, piping the data, same variables, age, death estimate, and grouping by sex. And the line type this time using geomline is going to vary by the sex categories. So 3 different line types. And you can also add points. You don't need to style the points. You can just add points at each age category to show the values and label them as normal. And this is kind of the basic chart again. So I'm going to apply the same kind of styling, get rid of this grey background and fiddle around with fonts and font sizes and these, the text, the colours of the text on the axes, and also angle them. But I'm also going to remove the legend and put the labels at the end of the lines. And I think that's a nice technique if you have either very few lines and they're separate like this, so the labels aren't crowding each other. It can look quite effective. But also if you do have many, many lines and you want to highlight specific ones, you can just put specific labels and specific lines to highlight certain aspects of your data. So the way you would do that is with the GG text package. And the first thing you need to subset data to create the data labels. And what you want to do is, for this case, is just look at the labels for the oldest age category, the maximum age category. So they go at the end of the chart, which would be the 85 plus category. Otherwise, if you don't do this, you'll get labels at every point and it looks silly and messy. So the same kind of thing as before, with geomline, removing the legend, getting rid of the legend, false. And with the GG text package, you use the geometry rich text function. You add the data labels that were created by subsetting the data. This, without this, you get boxes around the labels, which you might want. You might want boxes, and you can use this to sort of customize You can add colours to the background. You can add thicker borders, all sorts of different functions. But for this example, I've just got rid of the border around the text. And you want to put the labels based on the sex categories that you have in your data. And I think that, to me, I really like this. I think if you're wanting just a very quick to convey information very quickly about some trends across different age categories on this particular topic, I think that does the job, and I really like it. Maybe if you're presenting in a journal, peer-reviewed journal, or at a scientific conference, you may want something perhaps with some, you might want to include some additional information. You might want to have captions and references and different things like that. You may want to tweak it and style it. You may not. But I think that, to me, is quite clear and impactful. It sends a very strong message about what's going on based on these variables in the data, which is quite nice. So colours and patterns. As I've mentioned with scales and scaling, they're really, it's a package that exists on its own. It has lots of really fantastic features. You can change numbers and values and how things are presented, but it's included by default with ggplot2 anyway. And you can override things like breaks in your data. You can override labeling. You can add transformations, and I'll be looking at doing some log transformations. And you can customize palettes, as you've seen. They can improve readability. So applying colors and patterns might improve readability for people who can see. Check the default palettes. If they don't work for some groups of people, maybe use different colors or present data in a different way. And as I mentioned, patterns could be a personal preference, but it's a nice package. I think it's fun and it's interesting to play with. And if you are using color and shape and modifying it, don't forget to include scale shape manual and or scale color manual in your to modify your legend. Otherwise you end up with two legends, one for scale, one for shape, and that's not what you want. So I'm going to have a bit more of a look into themes and how to customize themes, have a look at guides and how you might apply them. So themes are really for, as we've seen, for non-data elements of a plot. So it's not going to be adding data. You're just going to be customizing fonts and styles and colors and positions of things. There are many built-in themes. You can create your own, which I'm about to show you, and you can save these as templates. So you're not having to do the same thing over and over again with the same code. And you can set a default theme at the start of a session with theme set, and then you give it the name of your theme, whatever it is. And you can create different themes for different types of plot or chart. If your organization has style guidelines, which it probably will do, you can do this. And here's just a very basic way to do that, basic function called theme scatter, setting the base size of the text to 14, using the theme BW. And what this does is it actually replaces the elements of the theme, whereas the plus sign on its own updates. So you can create your basic plot, as we've seen, and then update different features. This will actually just replace it with whatever you specify afterwards in this theme. So this is just a basic example, and you can look at all the different parameters for themes just to see what there is to tweak for whatever type of chart or plot that you're doing, what exists for it and how to use it. And it's incredibly powerful and quite a lot of fun, actually. It's if you like that sort of thing, which I do. So you can, like a demonstration, scatter plot and then add the theme scatter that's been created. And that creates the plot that we've already seen, but you haven't had to type all that code over and over again. You've just applied it. Guides are very nice as well. They can be used for fine tuning. And here, so this example on a line plot, taking the original line plot that I just edited and modified in the previous slide, you can modify the legend, specifying, you want to capitalize the label of the legend. You can add subtitles, as I've mentioned, with the subtitle argument and caption. You can put captions in for your data, and you can use guides. In this case, reversing the order of the legend. So it's both female, male, it's alphabetical order, but you can reverse it, male, female, both. And with the themes, you can also put the legend at the top or to the left or to the bottom. You can even position it within the chart itself by adjusting various parameters. And so that's that example. As you can see, it's been reversed using guides. Really handy functions to be able to really, nicely tweak the things you're doing. And again, coming back to scales, you can apply a log base 10 scale to your y-axis, which is really good if you have very small values, crude values or rates, and very large ones. It can be difficult to effectively compare properly. So you might want to scale. This Cohort Cartesian, this sets limits on the coordinate system, and it almost acts like you can sort of tweak this to kind of zoom onto different aspects of the plot. The clip off, what that does, it allows you to draw data points anywhere on the plot, including the margin. So the default is on because you want it to keep your points within the plot, but there may be times where you want that to not exist. It can produce unexpected results, but there may be a case for using it. And so you can apply a log scale to a plot like this. And again, I think that looks really nice, but you do need to be clear that you've used a log scale so that people are aware and they're not thinking this is actual number of deaths, because that can be a bit terrifying if you're not aware that, if the values look really, really big, then, people can start to panic about lung cancer deaths in Germany. So you do need to communicate that clearly. Plot layouts, I haven't included that here because I think the way the slides look or way they're set up, it looks really squished and ugly. But you can use things like grid arrange, patchwork, cowplot, these types of packages to organize different plots and different organizations. And the chapter of the book, I think, uses these sorts of things to very nice effect. So you can play around with those sorts of packages. Saving as an image, I often struggle with this. I think the resolutions, or, it might look the viewer screen, everything can look really lovely. And then you render it into an HTML file or a PDF or whatever, and it can just look ridiculous. The plot can be blurry or things can be oversized and not in proportion. It can be difficult to see. So with your function, you can set relative sizes. So when you're creating your function and you've got your base size of 14, you can create relative sizes. So this is a nice little feature. So your element text for your plot title will be relative to the base size. So here it'll be 14. And you can do this with text for your axes, where it'll be 90%. If you know how to convert between points and conversion rates and all this sort of stuff, you can work out what kind of point size that would be. But you can sort of reduce them a little bit relative to one another just to make them look in proportion. Again, you probably need to tweak it and play around with it. And you can modify legend text and legend keys as well to have certain types of fill if you want that or not, or you can make them transparent and add colors to backgrounds. But I think modifying the relative sizes of text can help when you're rendering to PDF. So you could have specific themes if you are producing PDFs to be able to do that nicely. And also within code chunks, you can set the aspect ratio. So the aspect ratio, if the width equals the height, the ratio is 1. The default in R is 0.7. You can also set the fig width and the fig height. So these, you could use these together, but you wouldn't use all three. You wouldn't use the aspect ratio and the width and the height. You could use either the width or the height and the aspect ratio, and you can play around with your charts and see how that looks like. But you can also tell R what your output width or your output height needs to be as a percentage. So you can include these in your chunk options. So if you know you want them to be a certain size, certain aspect ratio, width and height, you can do that first. And then finally, You can GG save your line plot or whatever your graphic is as a PNG. If you're using HTML, if you're rendering to HTML, I tend to prefer SVG format because it scales with the size of the screen. So whether you're on a mobile phone or a tablet or a desktop, it will scale perfectly without losing resolution or without things looking too big or too small. So that's just an extra little thing that tip that I like to use. And finally, things you can do to practice. So some examples, you might be doing this already, Tidy Tuesday, chart challenges, map challenges. There are probably other kinds of visualization competitions and challenges you could engage with. And I've added some additional information about accessibility because I've mentioned it a few times, and it's also my area, one of my areas of work in my job that I'm very excited about. Absolutely love it. Constantly learning new and better ways of doing things. And it's quite a broad term, but really what it means is that you're designing your products or services in such a way that people are not excluded from using it because of some disability or an impairment. And certainly in the UK, if you're working in public sector, everything you produce digitally needs to meet accessibility criteria as much as possible. So websites have to meet accessibility standards, minimum standards. And in my job, in my workplace, the idea is that we conform to web content accessibility guidelines. So there's level A, double A, triple A, and we're aiming for double A. So things to think about: contrast, making sure that things, you don't have pale text on a pale background. People can't see it or struggle to see it. Thinking about things like visual impairments to include blindness or low vision, also short-sightedness. I mean, ideally, you should be able to zoom into 400% on a web page without things flying off the screen, for example. There's also presbyopia, where your eyesight, as you get older, just being able to adjust between distances, long distance, near distance, gets harder. And you probably need corrective lenses to help you with that, or long-sightedness, hypermetropia. As I've mentioned, colour vision deficiency, and I've given some tips on things you can do to check for that and think about, and some definitions of different types of colour blindness or colour weakness, colour vision weakness. I was also quite remarkable. 12% of women possess supercolour vision, so can see more colours than trichromacy, red, green, and blue. So that's quite an interesting thing. And then I've provided information about contrast and the web content accessibility guidelines of at least a contrast ratio of at least 4.5 of regular text and at least 3 for large text, graphics, form input borders, and how that's defined. So if you wanted to, you could play around with checking. You could create a nice little function using values of red, green, and blue, and this equation to check for luminance of different colors. This is just the kind of standard red, green, and blue that you would get on a computer monitor. And it's actually quite useful to check the actual values of contrast instead of relying on what you can see, because what you can see could be very different, as I've highlighted, from what anyone else might be able to see if they have sight. So a couple of useful packages that have functions that you can play around with is Color Ratio by Matt Day, and the contrast ratio function in the color space package. For vision impairments, alternative text. I've added alternative text onto most of the visualizations in this presentation. I've still got a few to tidy up before I do a pull request. But there's a really nice blog post that gives a template really for writing alt text for charts, and some examples in the blog post of how you can actually do that with specific types of charts. And you can add alt text to code chunks, and also to, if you're adding images within the body of text in R, you can add alt text within curly braces next to the image reference link as well. Accessible data tables, alternative formats, so maybe you could produce a chart, but then being able to produce data tables in CSV or open document format, which is a freer format. There's free software available to produce that as standard. And I've included a link as well to examples of how to actually do that from the UK government analysis function and how to create accessible tables. There is a package called AFTable that will generate spreadsheets that have the best practice for accessibility, but you still need to go in and check. Like with any of these things, just relying on automation is not reliable because there can still be mistakes. So you do need to go in and check these things to make sure that they are actually doing what they should be doing. And then finally, some packages. This one for Shiny creates an overlay. So you create a Shiny app, you load the package, you put the app reference into the package, and it will bring up key points, things to think about. Does this meet contrast requirements? Is the text, is the markup right? So it will point out to you things you might need to fix. The Braille package provides support for blind users. It can use Braille conversion according to different standards. I don't know exactly how many different standards because each country has their own. Sonify is amazing, turns data into sound. So if you have a visualization, it can sort of read the visualization and convert it into sound, which is brilliant. And then Tactile R, so you can create a chart or a plot, and it will print onto that using Tactile R package, something that you can then put into a swell printer with swell paper. And what that will do, it will create bumps where it reads the lines or the dots or the boundaries or whatever it is so that people can actually feel your chart. And this is where I thought perhaps using pattern to differentiate between categories in a bar chart, for example, might actually be really useful. So you could feel differences between them instead of just relying on, I don't know, visual or text or whatever it is. So I think that's me. I think that's done. And I'm going to stop.